Hello, Algebra 2 AB. Today we're going to talk about Chapter 12, Day 5, which is talking about how to use inverse trigonometric functions, or inverse trig ratios. The other day we talked about Pythagorean theorem, we talked about special right triangles, and then also we talked about trigonometric ratios. So that should be some just introductory knowledge that you have coming in. Let's get started. So to solve a right triangle means to find the measure of all of its sides and all the angles. All right, using all of the tools that we have so far, including some of the ones that we're going to learn today, we're going to be able to find all the sides and all the angles in a right triangle. So you can solve a right triangle if you know either of the following. So if you know two side lengths, we can solve a right triangle. If you know one side and one of the angle measures of the acute angle, then we can solve this right triangle. All right, the sum of the three angles of a triangle is 180 degrees. That's something that we know previously from semester 1 when we talked about triangles. The sum of those three angles is 180 degrees. And we're going to use that to find some of the other angle measures within the right triangle. All right, so let's start by talking about the inverse trigonometric ratios. All right, to find angle measures with our calculator, we're going to use the inverse keys. Okay, so first, before we really talk about any of that, let's talk about like what an inverse trig ratio actually does. All right, so something that we know from previous sections is, let's say if tangent of A equals x, we know what that means. That's the ratio of the opposite over the adjacent sides with respect to that angle. So, you know, there's been times where we've set up or we found, you know, the tangent of some angle and maybe we got like 0.5, for example. Okay, if we have this type of equation, we can actually find the angle measure. So before we just set up this ratio and we found what this ratio was, but we didn't use it to find the angle yet. But we can find angle A. All we got to do is just figure out how do we get rid of this tangent. And that's where the inverse trigonometric ratios come in. Really, what we're doing is taking inverse tangent of both sides. All right, an inverse tangent gets rid of tangent. Okay, just like multiplication gets rid of division. All right, and that leaves us with A. So A would be the inverse tangent of that ratio, 0.5 for that example. All right, so that's all we're really doing to find those angle measures. Once we have that ratio set up, we can do inverse tangent, we can do inverse sine, we can do inverse cosine. All right, so I just want you to try these on your calculator just to make sure you get the right degree measure. And one thing that you're gonna have to do is you're gonna have to make sure your calculator is set for degrees. We talked about this before. What we're going to use is degrees. In future classes, you'll talk about radians and things like that, and maybe you'll use radians in those classes. But we're gonna just use degrees. Okay, so inverse tangent of 2/5. All right, if you type that into your calculator, you get 21.8 if we round. So that's 21.8 degrees. So if we know that with respect to an angle, the opposite over the adjacent sides is has a ratio of 2/5, then that angle measure is 21.8 degrees. And the next one, inverse sine of 1/2, if we do that, we get 30 degrees. Okay, and this actually comes from one of those special right triangles that we talked about the other day. Remember that equilateral triangle that we cut in half? All right, and that formed our 30, 60, 90 degree right triangle. What we're saying is if the ratio between the opposite side and the hypotenuse is 1/2, which is those ratios, if you remember correctly, for that 30, 60, 90 degree right triangle, that means this angle has to be 30 degrees. So it's really just using like proportions to figure out these angle measures. All right, so let's move on to some examples here. All right, so going on to the next example, we're going to find the following angles. So we want to find angle A in this first one. All right, so I'm going to just circle angle A. All right, that's the one that we're looking for. Now we're going to take a look at the side lengths that we have. 10 would be the opposite 16 would be the hypotenuse, right? And remember, this is with respect to angle A. So opposite over hypotenuse is talking about sine. Okay, it corresponds to sine. So sine of A equals 10 over 16. This is the same thing that we talked about when we talked about SOHCAHTOA. So we already have these skills to set this up. The only new addition is actually finding A. All right, so we take inverse sine of both sides, and that gets rid of sine. So really, A is just inverse sine of 10/16. And then we could just type that in our calculator. As long as you got that thing set to degrees, then you're all good. We're going to round to the nearest tenth, and that's 38.7 degrees. All right, if we take a look at the second one, now we're finding angle B. Now with respect to B, obviously 9 is the hypotenuse. I always suggest the hypotenuse being the first one that you mark down. That way the adjacent side doesn't get confused. And that means 6 is the adjacent side with respect to angle B. All right, so adjacent over hypotenuse refers to cosine. So cosine of B is 6 over 9. And then to solve for B, we're going to just do inverse cosine of 6 over 9. All right, and if we do that in the calculator, we get about 48.2 degrees if we round to the nearest tenth. All right, so once again, this is just using proportions, using ratios to find those angle measures, and we're just adding in that inverse sine, inverse cosine, and inverse tangent. Okay, all right, that's it. So now we're going to just continue, do a couple others, throw in some like real life problems, and then also talk about like solving a right triangle, how to find all those angles and all those sides. All right, so if we take a look at the next one, let me clear the board. We're going to solve this right triangle, all right, and we're going to round these measures to the nearest tenth. All right, so one of the key things is to take the information that you're given and then use that information to find something. You know, we just want to find anything. So if we take a look at this diagram, we have a 90-degree angle here. We've got a 31-degree angle here. All right, that's 2 angles out of 3 in this right triangle. All right, and we know the sum of the interior angle measures in any triangle is 180. So we could just take these two, find their sum, and subtract them from 180. All right, so that's 90, that's 31, which makes 121 degrees. If we subtract 121 from 180, all right, we get 69 degrees. Oh, that's not right. We get 59 degrees. What am I talking about? There we go, 59 degrees. All right, so the measure of angle A is 59 degrees. All right, and now we just want to find what are these two side lengths. All right, what I'm going to do is I'm going to mark this side with a letter, and that letter is going to be A. So opposite angle A, we have side A. Opposite angle B, we have side B. And opposite angle C, we have side C. Okay, so one of the things that I like to do is on the right side, I like to list out, okay, we're finding side A, B, and C. And then also, we're going to find angle A, angle B, and angle C. All right, I just like to do that just so that we don't miss anything, and then also it's kind of clearly noted like what our solutions are. So right now we can fill in some of this stuff. We know side C is 11. Okay, we know angle A is 59 degrees. We know angle B is 31 degrees. And then angle C is 90 degrees. So all we got to do is find A and B. So I'm going to erase some of this so it's not so cluttered here. Just put in some of the important stuff like that. There we go. And now what I like to do to find these side lengths is I like to use the angle that we were given originally. If we were given an angle, let's use that thing first. So we were given angle B originally. And now we can use angle B and a side that we already know to write some trigonometric functions to help us find A or B. So I'm going to elect to find B first. Okay, B is opposite of angle B. Okay, so we have the opposite side here, and then of course this is the hypotenuse. Let me just mark that down so you can see that. All right, opposite over hypotenuse refers to sine. So sine of 31 degrees equals b on 11. Now to solve for side b, we just multiply by 11. So b equals 11 times sine of 31 degrees. All right, if we type that into the calculator, we get approximately 5.7. Now I'm going to put that solution there. Now we're going to move on to finding A. Now A would be the adjacent side to angle B. Now one thing that I always like doing, I like to be consistent and keep working with that same angle. That way we don't get confused about like what trig ratio we're actually using. So to find A now, we're talking about the adjacent side. We already know the hypotenuse. Adjacent over hypotenuse refers to cosine. So cosine of 31 degrees is A on 11. And to solve for A, we just do the same thing. Multiply by 11 on both sides, and we get 11 times cosine of 31 degrees. All right, so for A, we get 9.4. And then we always just want to double check and make sure, okay, does this make sense? And one way to figure that out is just to look at like the angles and the side lengths opposite those angles. All right, so obviously opposite the 90-degree angle should be the longest side, which it is. All right, opposite the middle angle, you could say, the medium angle would be the medium side, and then opposite the smallest angle should be the shortest side. And we do have that, so at least, you know, reasonably it makes sense. All right, that's not ensuring us of anything, but at least it makes sense. All right, so let's move on to the next one. Clear the board. Here we go. All right. All right, let's look at this next one. So now we're starting with two side lengths. All right, whenever we have two sides out of three in a right triangle, we can find that third side. So we could find B pretty easily here. Let's just use Pythagorean theorem. So that's 6.6 squared equals 3 squared plus B squared. All right, now we're just going to solve from here. So to get B squared isolated, all we have to do is subtract 3 squared from 6.6 squared. Okay, so you can type in straightforward 6.6 squared minus 3 squared in your calculator. You get 34.56 approximately, and then take the square root, and we get 5.9 if we round to that nearest tenth. Okay, now we have all three sides on the triangle. So once again, like before, I'm just going to write A, B, C, angle A, angle B, angle C. Let's fill it in with what we know. We know side A, okay, is 3 units. We know side C is 6.6. We just found side B, which was 5.9. And then also we know angle C is 90 degrees. All right, now we just need to find angle A and angle B. To find those angles, we need to use inverse trig ratios. So first, let's set up a trig ratio. Okay, so one of the things that we could do is, one of the things that we have to do is pick an angle to find. All right, so I'm going to say, let's find angle A, for example. And then also, I don't want to use this side length because, for example, like, what if I got that wrong? Okay, or what if, you know, this decimal doesn't terminate, it keeps on going farther than, you know, the nearest tenth. Maybe if I'm off in terms of my rounding or it's not completely accurate, I'm not going to get accurate solutions for these angles. So once again, I like to use the information that was straightforward and given in the problem. Now, with respect to angle A, we have 3, which is side A, which that's opposite angle A. And then we are also given the hypotenuse. Opposite over hypotenuse refers to sine. So we can set up sine of A equals 3 on 6.6. And now, like we just discussed, to get rid of sine, we just take inverse sine of both sides. So we have A equals inverse sine of 3 on 6.6. Okay, and then when we solve for A, we get about 27 degrees. And now it's up to you. We don't have to go through this whole thing again to find angle B. What we could do is just, we've got two angles out of 3 in a right triangle. We could just subtract those sums from 180 Okay, and then we would get 63 degrees. All right, so that's basically the process of how we would solve those right triangles. We started with an angle on a side, and then two sides. All right, and we were able to find the rest of the angle measures and the rest of the side lengths. All right, so let's take a look at some other examples here. All right, so we're going to just go run through a couple like real life scenarios, maybe not real life scenarios, but real world context problems. This says the top of a ladder rests against a wall 23 feet above the ground. The base of the ladder is 6 feet away from the wall. What is the length of the ladder? And draw a little sketch. First thing that we want to do, we always want to draw a diagram. And it doesn't even have to accurately represent the scenario. It's just like a picture that we can look at that we can use to help us solve the problem. All right, so I'm going to draw a diagram. Oops, can't use that one. So we've got the top of a ladder resting against a wall. So here's our ladder. Okay, it's resting against the wall. And obviously here's the distance between where the ladder is on the ground and where the wall is. All right, this is not an accurate representation of the scenario. It doesn't look like this, but that's okay. All right, so top of the ladder rests against the wall 23 feet above the ground. Okay, so this point is 23 feet above the ground. That's talking about this length here. So I can write down 23 feet. I can also fill in, hopefully that wall is perpendicular to the ground, I hope. And then the base of the ladder is 6 feet away from the wall. Okay, what's the length of the ladder? Here's the ladder. Obviously, we're finding this side length. All right, so with this sketch, we can see that we got 2 sides out of 3 in this right triangle, and we can just use Pythagorean theorem. That's L squared equals 6 squared plus 23 squared. All right, so 6 squared plus 23 squared is 565. And then if we take the square root, we get about 23.8 feet. Okay, when we're drawing a sketch, it's pretty simple. It's pretty straightforward. We take a look at the picture, and using our skills that we know, how would we solve for what we're looking for? All right, let's move it on here. All right, the body of a dump truck is raised to empty a load of sand. How high is the 14-foot body from the frame when it is tipped upward at an angle of 45 degrees? So this diagram is kind of already given to us, like this is what we're talking about. Let me use different colors so you can actually see that. You know, this is the triangle we're talking about here. I'm just going to redraw it on the right side here. Okay, it's saying that how high is the 14-foot body? It's talking about this. This is 14 feet long. That's talking about the hypotenuse. And remember, it's asking how high. It's asking for the height. Okay, so that's going to be what we're looking for. So that's how we know that that's not 14. And then it says when it's tipped upward at an angle of 45 degrees. Okay, that means like when it's tipped upward at an angle, that's kind of like angle of elevation is what we might call that. Okay, so if we take a look at that, all right, the angle of elevation is 45 degrees. All right, and this is a 45, 45, 90 degree right triangle, so we don't need to use trig ratios here. We just got to find the leg given the hypotenuse. All right, which means we would divide by root 2. Remember those ratios are 1, 1, root 2. 45, 45, 90. Now we got to rationalize the denominator. So multiply by the square root of 2 over the square root of 2. That's 14 times the square root of 2 all on 2. And then 14 divided by 2 can be simplified, so we have 7 root 2. All right, and since this is talking about a real life problem, all right, not many people probably know what 7 root 2 feet is, so let's type that into the calculator and let's round, and we get 9.9 feet. All right, we got 2 more. All right, in this next one, a flagpole casts a 12-foot shadow. So already I'm going to start drawing the diagram here. Here's our flagpole, and then here's the shadow it's talking about, 12 feet. Okay, it says viewed from the end of the shadow right here, the top of the flagpole makes a 65-degree angle with the ground. So this angle here is 65 degrees. What is the height of the flagpole? That would be this distance here. Okay, now we got our diagram. All right, hopefully the flagpole once again is perpendicular to the ground. And now we can set up a trig ratio. All right, with respect to that 65-degree angle, we're looking for the opposite side. We have the adjacent side. That refers to tangent. So tangent of 65 degrees equals h on 12. Multiply by 12 on both sides. We get 12 times tangent of 65 degrees, which is approximately 25.7 feet. All right, last example. Gotta clear the board. A skateboard ramp has an angle of elevation. Angle of elevation, once again, just means we can think about it as, let's say we're looking out at the horizon, okay, and we're gonna just draw like a horizontal line across the page. All right, angle of elevation means we're going up. Okay, angle of depression would mean we're going down. All right, so angle of elevation means, okay, if we're looking out at the horizon, 10 degrees up from that. And there we go. We can form our triangle now. All right, so this is 10 degrees. All right, hopefully that doesn't look like 100. And then the height of the ramp, which is right here, is 1.5 feet. And we just want to know what's the length of the ramp. All right, maybe we know we want it to be like 1.5 feet tall. We just got to figure out, okay, you know, how much wood do we have to buy to build this ramp? With respect to that 10-degree angle, we have the opposite side. We're looking for the hypotenuse. That refers to sine. So sine of 10 degrees equals 1.5 on L. Now to solve for L, okay, if we remember our trick here, we can just switch these. And we remember why that happens. That's just because of what we do algebraically to solve, or we could just algebraically solve it if that's what you want to do, if you don't remember that trick. And we have 1.5 over sine of 10 degrees, and that's about 8.6 feet. Okay. All right, folks. That's all we got for today. Just solving right triangles, using inverse trig ratios, and then solving real-life problems. It's amazing how much like trigonometry is embedded in the technology that we use in just our everyday life. It's awesome. If you have any questions on homework, please let me know. Thank you and have a good day.